Welcome again, everybody. This is Petter. You've seen him before today. Today, he's going to not have you pick between security and performance.
Thank you. So, we have quite short time, so I will keep it short. Usually, when somebody says security, okay, security, it means that the performance will go down, right? That's the usual notion. So, first we will look when we care about the DNS performance, then we look what's the so-called random subdomain attack, what's the DNSSEC aggressive cache, and how it plays together. So, performance under stress basically means that your infrastructure is under attack. And if you mean it seriously with DNS, there is no other way than over-provision heavily, which in practical terms means that the normal traffic is not interesting at all, because it's way lower, it's like 1 order of magnitude, for example, lower than the traffic you have to handle to withstand some modest denial of service attack, right? It practically means that when you add some security sugar on top of it, you will not notice performance-wise, because you still need to over-provision for the denial of service attacks anyway. So normal traffic is not interesting from performance perspective. When somebody is attacking you, you need to handle a lot of traffic, so any means how to reduce the amount of traffic you have to handle is a good way. And you need it badly. And please keep in mind that when we talk about the denial of service attacks, there is nothing like guarantee that the system will survive. We can only make it a little bit more resilient, but nothing is going to guarantee that your domain will be up. If the attacker can push 100 gigabits per second and your line have only 10, then, well, there is nothing to do about it. So we just want to increase the cost for the attacker and decrease the cost for us as defenders. So when you add DNSSEC, of course, the data in the zone file will be bigger and the packets will be bigger, but under normal circumstances, which means not under attack, it's practically not interesting, because the over-provisioning for attacks is so big that you just don't care under normal circumstances. So now, attacker wants to flood us with a bunch of queries, and what are the options? Of course, he can spoof IP address and so on, but that's kind of easier. Well, there are ways how to deal with it. But there is one particular nasty attack, which from the attacker doesn't require basically anything special. It might be just a web page with a little piece of JavaScript. And if you get, or if the attacker gets the JavaScript, for example, into advertisement platform, it will get distributed to thousands and tens of thousands and potentially millions of computers. And the only thing with the JavaScript needs to do to run the attack is to load or attempt to load a picture or some other web object from randomly generated name, which is just some garbage, dot, and the domain under attack. So in this example, the domain under attack is www.example.com. This JavaScript or this attempt to load objects from web will trigger DNS query using the very standard DNS API. So there is nothing suspicious per se, so the operating system have no way to detect this at the first try. And it goes through the layers of the operating system API, then to the recursive resolver of your ISP or home router or something, and then the recursive resolver goes and attempts to contact the authoritative server. Of course, at this point, the authoritative server is getting millions of queries from all over the place, because the query rate from every single client might be like 100 or 10 queries per second, but if you have million clients, then you are doomed. So for the attacker, it's super easy, super cheap, and that's a problem. We want to make this more costly for the attacker and cheaper for us as defenders. So now there is a new fancy technology which is finally implemented and released into resolvers, which is called DNSSEC aggressive caching. Basically, the idea is very simple. In DNSSEC, if you ask for a name which doesn't exist, you get back something which is called proof of non-existence. And the proof says basically, in the zone, we query for name example, right? And on the public internet, there is nothing like top-level name example. So the proof of non-existence says there is a name which is Everbank, then nothing, and the next name which exists is exchange. This is a real example. And this data plus the cryptographic signature, which is not on slide because it's this big garbage, proves that there is nothing like that, and the resolver will reply to the client, NX domain, no such name, and so on. And the trick we are talking about here, the aggressive caching, is basically storing this proof in the cache and reusing it again for new queries, which we haven't seen before. But if you imagine that first we queried for the example, it doesn't exist. We get a proof. The proof gets stored to the cache. And then we get new query, which is example 2 or example EEEE or something like that. It's still lexically between the Everbank and the exchange. So when the resolver finds in its cache this proof, it doesn't need to go and contact the authoritative server, right? Because there is no point in doing that. There is TTL, time to live, 1 hour. So for 1 hour, we don't need to contact the authoritative server again, which might be a huge help under attack. So in practice, if the DNSSEC domain is signed, using NSEC at the moment, but that's technical detail, it will just work. Over the time, the resolver will fill its cache with the proofs of non-existence for various pieces of the namespace. So over time, it will quite quickly build basically coverage of the all namespace, so the random queries will be hitting just the data in cache and will not get forwarded to the authoritative server. So the authoritative server will see short peak because the caches on the recursive resolvers are still not filled, but the peak will very quickly go down and stay down for the TTL. So after 1 hour there will be peak again because the records expired, and then it will fall down and hopefully stay flat. So for the attacker, this complicates situation a lot because, well, now it's not enough to push little pieces of JavaScript around, and he needs to do something more clever. And for the defender and for the guy who operates the resolver, it's super easy because it basically means install sufficiently new version of recursive resolver and that's it, because it doesn't require any configurations, the protocol, right? So of course it helps only with signed domain. So if your domain is not signed, too bad, there is no way to detect this automatically, and all the resolvers or operators of resolvers have to rely on some heuristics, which is nightmare to set properly. Of course, if it's 3 in the morning on Saturday and phone rings, you are not up to tweaking the little knobs in the configuration of resolver and finding the right values for the heuristics. So to sum it up, please sign your domain. It will help you and others. And if you are operating a recursive resolver, please validate. Usually it just is flipping one switch somewhere and it's mostly done. So install sufficiently new versions. Bind 9.12 can do aggressive caching. Not resolver 2.0 can as well do aggressive caching. So pick one of these hopefully the others as Unbound and Power DNS will join us. And if your domain is not signed because it's hard to configure and so on, have a look at the .dns authoritative server. It's super easy. It's basically one switch. It has reasonable defaults. It will sign the domain, and all you need to do is to push the public key to the parent domain, and that's it. And for some TLDs like .cz, you don't need to do even that, because the TLD will find the key automatically, and using some magic process, it will upload it. So.
We had a talk on that, but I couldn't fit it in.
Sorry. Okay, so we have a couple minutes for questions, right?
After from Nick.at, does it also work with NSEC 3 and with NSEC 3 with opt-out?
Of course, if there is opt-out in your zone, it will not work because it doesn't prove anything, right? But if you are owner of DNSSEC, DNS zone and you are not COM, don't use opt-out, that's it. I mean, opt-out is insecure by definition, so it's for special cases, for huge zones like .com, which has 100 million names in it. If you are not signed, which are not signed, yes. If you are not COM domain, don't use NSEC 3 opt-out, that's it.
But will it be, so for example, .at uses NSEC 3 with opt-out. So
yes.
Will it cause problems if resolvers start the aggressification?
No, the resolver will detect it and will not do anything interesting, too bad. But how many domains do you have? I'm curious.
Signed or?
Well, at
1.2 million, but
yeah,
not much.
I mean, it's, sorry, but I wouldn't use opt-out. It's like, you know, decreasing security for everyone for little benefits. I mean, 1 million domains is like peanuts. Sorry. It's
depends. If you use bind, then it's okay. If you use not as the name server, you need twice the memory.
Next question.
Yeah, that's correct, but I mean, peanuts.
Over 16 million .de domains we're using NSEC 3 with opt-out because there is a very huge unbalance between what's signed and what it is not. So we are doing opt-out, and I can just say it's a memory issue that we are running.
Yeah, maybe I should add that the opt-out makes sense for TLD, right? Because the TLD is so heavy over provisioning that, well, the aggressive caching for you as TLD operators is not that interesting. It's way more interesting for the guys down there because their over provisioning is not that big. So if you have like domain example.com, don't use opt-out. It's like pointless for you to use it. It just decreases security. So thank you for...
It depends on really on the name server you use. But like if you use not NSD, the random subdomain attacks don't hurt you that much as if you use like Power DNS with a database backend, then it really hurts you.
Well, it depends, of course. If the attack is small enough, you can handle it on your server. If it's big enough, it will just fill the link, and too bad. And there is no way for you how to stop the attack if the link is full. So the trick of the aggressive caching is that it doesn't even get to your server. So then there is nothing you need to do. Okay, I think time is up, so thank you for your attention.